Isang magandang buhay para sa ating lahat. So now we are going to discuss the introduction for the steel and timber design. The term structural steel refers to a number of steel that, because of their economy and desirable mechanical properties, and suitable for load-carrying members in structures. So the customary way to specify structural steel is to use an ASTM, or American Society for Testing and Materials designation. For ferrous metals, the designation has the prefix letter of A followed by two or three numerical digits. For example, we have the ASTM A36 or ASTM A514. Ito yung mga example ng mga steel. Special type of steel that, as the name suggests, has a higher concentration of carbon than other type of steel. So most type of steel have a relatively low carbon content of about 0.05% to 0.3%. In comparison, carbon steel has a carbon content of up to 2.5%. So, yun yung carbon steel. So, kasi yung ginagamit ng carbon steel as cheap strengthening element with minimum yield stresses ranging from 220 megapascal to 290 megapascal. So, an increase in carbon content raises the yield stress but reduces ductility, making welding more difficult. For the HSLA, or high strength low alloy steels, so we have a type of alloy steel that provides better mechanical properties or greater resistance to corrosion than carbon steel. So it varies from other steel in that they are not made to meet a specific chemical composition but rather specific mechanical properties. They also have a carbon content between 0.05 to 0.25% to retain formability and weldability. It yields stresses from 480 megapascal to 840 megapascal. In addition to carbon and manganese, this steel contains one or more alloying elements such as columbium, vanadium, chromium, silicon, copper, and nickel. For quenched and tempered alloy steel are processes that strengthen materials like steel and other iron-based alloys. So these alloy processes strengthen the alloys through heating and the material while simultaneously cooling in water, oil, forced air, or gases such as nitrogen. It yields stresses to 480 megapascal to 690 megapascal. These steels of higher strength are obtained by heat treating low alloy steels. So the heat treatment consists of quenching, grade cooling, and tempering or reheating. For the material conforming to one of the following standard specification is approved by the use of according to the section 501.3.1.1 of NSCP. So we have the structural steel, ASTM 3036. So we have the pipe steel, black and hot dip zinc coated, welded and seamless steel pipe, ASTM 853. We have grade B, high strength in alloy, or high strength alloy low alloy structural steel, which is ASTM A242. So we have also high strength low alloy structural manganese vanadium steel, that is ASTM A441, cold formed welded and seamless carbon steel structural tubing in round and shapes. So we have the material conforming to yan, steel pa rin. We have the ASTM A500 or A500. So hot formed welded and seamless carbon steel structural tubing or ASTM A501 yields or high yield strength, quench and tempered alloy steel plate suitable for welding or ASTM 514. We have structural steel with 290 megapascal minimum yield points. So we have ASTM A529 steel sheet and strip carbon hot rolled structural quality I mean. So we have ASTM A570 grade 275, 310 and 345. So yun yung mga example namin. So we also have a high strength low alloy vanadium steel structural quality ASTM A572. So we have high strength low alloy structural steel with 345 megapascal minimum yield points to 100 millimeter thick ASTM A606. Hot form welded and seamless high strength low alloy structural tubing ASTM A618. We also have structural steel for bridges, that is a ASTM A709. Quenched and tempered low alloy structural steel plate with 3 megapascal minimum yield. So we have the strength to 100 millimeter thick STM A852. So note, we have the certified mill test reports of certified reports of tests made by the fabricator or testing laboratory accordance with the ASTM A36 or A568 as applicable, and the governing specification must constitute evidence or of conformity with one of the above ASTM standards. Additionally, the fabricator must provide an affidavit stating structural finish meets requirements of the grade specified. So we have the properties of steel. So we have the first one, we have yield stress. Unit tensile stress at which this is stress strain curve exhibit in a well-defined increased strain or deformation without an increase in stress. So the yield stress can be determined how far the material can be bend before taking permanent damage. So ibe-bend mo yun, pagka-bend mo, kailangan hanggang sa bago siya ma-deform or masira bago gano'n. So, di ba parang ganito? Ayan. So, this will be the example of yield stress. Hypothetical to, ha? Ayan. While for the tensile stress, that is the largest unit stress that the material achieves in a tension test. So, tensile strength is resistance of steel to be breaking under tension. When two equal and opposite pulling forces is applied over steel specimen, stress is developed, known as tension stress, which causes stretching or elongation in specimen. So tensile stress of steel is maximum strength of steel to resist or withstand against tension stress prior to failure at the end of the plastic stage. So modulus of elasticity, the slope of the initial straight line portion of the stress strain diagram. It is usually taken as 200,000 megapascal for design calculation for all structural steel. The ratio of the stress strain of an elastic substance. So these are the modulus of elasticity in terms of ASI. and wood, concrete, and structural steel. So ductility, the ability of the materials to undergo large and elastic deformation without fracture. Ayan. Kumbaga, pag ibinanat mo or hinila mo gano'n, no? Hanggang sa dulo bago siya maputol, yun yung kanyang ductility. So with toughness, ability of the material to absorb energy and is characterized by the area under stress strain curve. Weldability, ability of steel to be welded without changing its basic mechanical properties. Actually, pagka nagwe-welding ka, dapat pag wineld mo after weld, huwag mo siyang bubusan ng tubig or sometimes, kumbaga, hayaan mo siyang lumamig. Kumbaga, makuha niya yung pinaka natural temperature niya para at least mas matibay yung inyong wineweld ng mga steel. So we have Poisson ratio, the ratio of transverse strain to longitudinal strain. So we have Poisson's ratio is essentially the same for all structural steel and has a value of 0 in elastic range. For the shear modulus, ratio of the shear stress to shearing strain during the initial elastic behavior. So these are the values for the A36 steel. We have modulus of elasticity, yield strength, tensile strength, endurance strength, density, Poisson's ratio, shear modulus, and coefficient of thermal expansion. These are the values. Structural steel are available of many shapes, so the dimension of weight must be added to designation of unit to identify the shape. So we have the W, for example, W40 by 436 refers to W shape with an overall depth of approximately 40 inches or 1,000 millimeter that weighs 436 or pound per feet or 640 kilogram per meter. So these are the example. We have W shape, H shape, C shape. Ayan yung mga example natin. So we have also yung plates, ayan, bars, tubing, tsaka yung mga pipes, steel pipes. So these are the structural shape designation. We have wide flange beam, which is W or I beam. So American Standard beam, we have the S, bearing pipes, we have channel, angle bar, for structural T, structural tubing, pipe, plate, and bar. So these are the combination section, combination of channel and I-beam or W-flange section that are made combining two basic structural shapes, also referred to as built-up sections. So these are yung mga example. Pinagko-combine yung mga steel or connection. Yung iba dyan, wineweld, yung iba binawitan ng bolt. Ganun. There are three basic types of construction and associated with design assumption permitted, and each will govern in a specific manner the size of members and the types of strength of their connections. So we have rigid frame. The commonly designated as rigid frame or continuous frame assumes that beam column connections have sufficient rigidity to hold virtually unchanged the original angles between intersecting members. We have also simple framing, so commonly designated as simple framing, unrestrained, free-ended, assumes that insofar as gravity loading is concerned, ends of beams and girders are connected for shear only and are free to rotate under gravity load. So lastly, we have the semi-rigid framing or partially restrained. So assumes that the connections of beams and rigid girders possess a dependable and known moment capacity intermediate in degree between rigidity of type 1 and the type flexibility of type 2. So ito example ng mga semi-rigid. So we have double web angles. So yan, kumbaga yung mga ginagamit natin. So we have load and stresses. So structures are designed to resist many types of loads, including the dead loads, live load, wind load, and earthquake loads. So the complete design must take into account all effects of these loads, including all applicable loads combination. We have dead load and live load. So the dead load to be assumed in design consists of the weight of the steel work and all materials permanently fastened or supported by it. So ito yung example ng dead load natin. Yan, sa structure. For the live load, so we have it must be the stipulated by the applicable code under which the structure is being designated or that dictated by the conditions involved. For the wind and seismic stresses, so allowable stresses may be increased one-third above the values otherwise provided when produced by wind and seismic loading, acting alone or in combination with the designed dead and live loads, provided the required section computed on this basis is not less than that required for the design dead and live load and impact. Computed without the one-third stress increase and further provided the stresses are not otherwise required to be calculated on the basis of reduction factors applied to design loads in combinations. So these are the example of loads. Lalo pagka yan, seismic load, earthquake. Yan nangyayari. Okay, so impact loads. So we have ito yung mga for structure carrying live loads which include induced impact. The assumed live load must be increased sufficiently by the percentage provided in table shown below. So we have for the elevator at least 100%. Cab operated traveling crane supports girders and their connections. We have 25% of the impact loading factors. We have dependent operated traveling crane supports girders and their connections. We have 10%. For the light machinery, shop, or motor driven, we have 20%. Recipro- Reciprocating machinery or power driven units, we have 50%. So hangers supporting floors and balconies, we have 33%. So these are the impact loads. So this will end our module for lecture for the introduction of the steel and timber design. Thank you. Ciao.